After a brief stint with straight lines, we've learned some of the basic ideas, basic concepts, also looked into some elementary problems. The next sheet is just application of those basic applications, basic concepts. Let's start looking at these problems together. This sheet titled Straight Lines, Raise the Bar. Raise the bar doesn't mean that it's going to be a difficult sheet. It just means it's going to be slightly different. We'll put together all the ideas in one single place and apply them in these problems. That's what we are essentially going to do, right? So, straight lines. Raise the bar. All right, so the first problem of the sheet is about a pair of straight lines, represented by a generalized second degree equation in x and y. Okay. Now what we want is, we want the two lines represented by this to be equally inclined with the x-axis. This is what we seek to do, right? The two lines that are represented by this equation, we want the two lines to be disposed as follows. These are the two lines represented by this, and they are not parallel to each other. One way they can be equally inclined with the x-axis is if they are parallel. But they are not parallel, right? They intersect therefore. And say if one of the lines makes an angle theta like this, then the other line would make an angle theta like this, That's when they are equally inclined, right? Now if the slope of this is tan theta, then what would be the slope of this? This is pi minus theta. So the slope of this is going to be minus m, right? The slope of this is going to be tan pi minus theta, which is minus tan theta, which is minus m. Yes or no? So if the slope of one of them is m, the slope of the other one is minus m. Yes or no? Right? Do you understand this? Huh? Which means, say if one of the lines is of the form Lx plus my plus n equal to 0. Let me not use m here because I have already deployed m. Let me call, if one of the lines is px plus qy plus r equal to 0 is one of the lines, right? Then the other line would be of the form px minus qy plus r prime equal to 0 would be the equation of the other line. Do you realize the slope of this line is minus p by q, the slope of this line is p by q, right? So if the slope of this line is m, then the slope of this line will be minus m. The form of the equation of the two lines equally inclined with the x-axis would be this. Do you all understand this? No, you didn't understand this, no? Ayush, did you understand that the two lines equally inclined with the axis is going to be m and minus m? What's the slope of this line? Minus p by q, right? What's the slope of this line? P by q. So if the slope of this line is m, the slope of this line is going to be minus m. Which is the same thing, does not matter. How does that matter? I mean, you can transpose this and you can call it minus px plus qy minus r prime equal to 0, right? That wouldn't make a difference, right? Which means it's possible to factorize this expression ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c could be factorized as this into this. This is what it means. Could be factorized as this into this. That means this must be some px plus qy plus r into px minus qy plus r prime. Right? If this is capable of representing these two lines, that means it should be possible to factorize this second degree expression in x and y as px plus qy plus r into px minus qy plus r prime equal to 0. That means when this is 0, then either this is 0 or this is 0, representing the two lines with slope mn minus m respectively. Is it confusing? No. Now, notice if this is the form of the expressions that represent the two lines, then realize what's the coefficient of xy on the right hand side? P into minus q plus q into p. What is that? 0. 0 is the coefficient of xy. See? P into minus q, xy, and p into q, xy. So pq minus pq, which is 0. So coefficient of xy in this is 0. So if when you factorize something, you are creating an identity. Factorizing something means creating an identity. That means this will be identically equal to this. That means if the coefficient of xy is 0 here, then the coefficient of xy must be 0 there also. That means, do you all realize this? Coefficient of xy on the right hand side is 0. What should be the coefficient of xy on the left hand side? 0. So 2h must be 0. That means h must be 0. Right? So this means that h must be 0. So this from now on you might also want to remember as a standard result. If this represents a pair of straight lines equally inclined with the x-axis, then h must necessarily be 0. Got me? Okay, how many of you got it right independently? Okay, very good. What did you do?
So I did it m1 plus m2 equals to 2h by minus 2h by b.
m1 equal to minus m2. So h is 0. Very good. Excellent. Excellent. Very nice. Very good. Very good. So let me also tell you what he did. In this case, hey, this is a good bunch of students, you know. This pair of lines will be parallel to this pair. Ax squared plus 2hxy plus by squared equal to 0. Like I told you in the last class, if you just populate the second degree terms, then this pair will be parallel to this pair. And if that means if the slopes of these are m1 and m2, then if the slopes of these two lines are m1 and m2, then the slopes of these would be also m1 and m2. That means sum of the slopes of the two lines is m1 plus m2, which is minus 2h by b. And in this case, m1 is m and m2 is minus m. So m1 plus m2 is going to be 0, is minus 2h by b, causing h to be 0. Perfect. Perfect. Very good. Very good. No, you lost? Perfect, right? So h is 0. Let's look at the second problem. Problem number 2. So we have the origin 0, 0, and we have a straight line which is 2x plus y minus a is 0 is a straight line, right? Now from the origin, two perpendicular lines are drawn forming an isosceles triangle with this line. This is the origin, and I draw two perpendicular lines. OA and OB are perpendicular lines. Two perpendicular lines are drawn such that this is a right angled isosceles triangle. Right angled isosceles triangle, if this is 90 degrees, OA equals OB means this must be 45, this must be 45, right? And what I want to find is the area of triangle OAB. What I want to essentially find is area of triangle OAB. Now I can find the perpendicular from O onto this line, that is P. P is the length of the perpendicular from the origin onto this line, right? Now, how do you find the length of the perpendicular from the origin onto this line? Replace x by 0, y by 0, take the modulus of this and divide by root 2 square plus 1 squared, right? That's the perpendicular distance from the origin onto the line. So, P then is 2 into 0 plus 1 into 0 minus a divided by root 5, which is mod a by root 5 is the perpendicular distance, right? Now, realize that if this is 45 degrees, this is 90 degrees, this will also be 45 degrees, right? Now, if this length is P, then AD will also be P, DB will also be P. Yes or no? Half base into altitude. Half of base is P, altitude is P, isn't it? So, area of triangle OAB is half of base. Half of base is half of 2P into P, which is P square. P square means A square by 5. Perpendicular distance of a point from a line. How do you find perpendicular distance of 0, 0 from this line? Replace x by 0, y by 0, mod of this, divide by root 2 square plus 1 square, which is root 5, right? Perpendicular distance of a point from a line. How many of you got this right? Did this or something else? Longer? Brute force? No, that's all right. As beginners, one way or the other, if you get it right, that's all right. You're learning, your problem solving skill will get refined over a period of time. That's all right. This is your learning phase. Even if you solve a problem using brute force, 100 marks to you, right? Okay, let's look at problem 3. Problem number 3. So there are two lines. One is 3x minus 4y plus 12 is 0 is one line, and there is another line which is 12x minus 5y plus 7 equal to 0 is the second line, right? Now we want to find, so there is a point P 1 comma 4 that lies in one of these four regions, right? We now want to be able to find the equation of the angle bisector. We want to be able to find the angle bisector that contains 1 comma 4. That means instead of using origin as my reference, is it minus 1 comma 4? Okay, minus 1 comma 4. So the problem says minus 1 comma 4, not 1 comma 4. So this is the angle bisector A1, not measured in terms of containing the origin, but this time measured in terms of containing the point P. Minus 1 comma 4 is a point P which lies somewhere in this region. I want to find the equation of such an angle bisector, right? Whatever be it, the two angle bisectors are as follows: 3x minus 4y plus 12 divided by 3 square plus 4 squared 5 equals plus minus 12x minus 5y plus 7 divided by root 12 square plus 5 square, that makes it 13. These are the two angle bisectors, right? I want to figure out whether plus would give me the angle bisector containing minus 1 comma 4, or the minus sign would give me the equation of the angle bisector containing minus 1 comma 4, right? Now see, if M h comma k be a point on this angle bisector, right? Do you realize minus 1 comma 4 and h comma k should give me the same sign for this expression? Why? Minus 1 comma 4 and h comma k lie on the same side of this line. Now, let me examine what minus 1 comma 4 imparts to this expression, right? So, minus 1 comma 4 imparts to this expression 12 into minus 1 minus 5 into 4 plus 7. Hey, it's a negative sign. Minus 1 comma 4 imparts a negative sign to this expression, right? So h comma k, which is a point on this angle bisector, must cause this expression to be negative, right? That means for sure 12h minus 5k plus 7 must be less than 0 if hk is a point on this angle bisector, right? Now, minus 1 comma 4, let's see what it does to this expression. 3 into minus 1 minus 4 into 4 plus 12. Hey, minus 1 comma 4 imparts a negative sign to this expression as well. That means, now refer to this line, 3x minus 4y plus 12 equal to 0. Minus 1 comma 4 and h comma k lie on the same side of the line, and therefore the 2 points must impart the same sign. They lie on the same side, must therefore impart the same sign to this expression. That means h comma k will impart to this expression a negative sign. Why? Because minus 1 comma 4 is also imparting a negative sign, and they lie on the same side of the line. That means 3h minus 4k plus 12 will also be less than 0. If hk is a point on the required angle bisector, then this must be satisfied and that must be satisfied. Now, let me see. So, between plus and minus, hk will satisfy one of the equations. Yes or no? So, hk will cause this to be negative. hk will cause this also to be negative. The two negative numbers must be connected with a positive sign. Yes or no? If this is negative and this is negative, then the sign between them must be positive. Yes or no? That's when a negative could be equal to a negative. That means h comma k will be satisfied by a plus sign. The plus sign will satisfy. Yes or no? The point m h comma k on the required angle bisector will satisfy an equation with a plus sign. Because when I use a plus sign, then 3h minus 4k plus 12 by 5 will be less than 0, and 12h minus 5k plus 7 will be less than 0, causing the two negative numbers to be equal. Right? Otherwise, if I use the minus sign, then this would be negative. With the minus sign, right hand side would be positive, left hand side would be negative. That's not possible. Therefore, this is connected by a plus sign. This is connected by a plus sign. This, therefore, must represent the angle bisector containing minus 1 comma 4. Do you all understand this? No confusion? Right? How many of you got this right? Okay, very good. Excellent. Excellent. What does the answer turn out to be finally? Option A. 21x plus 27y minus 121. So, I'm told that on simplifying you get 21x plus 27y minus 121 equal to 0 is what you get on simplifying. Right? You checked it? Okay. Let's look at the next. Now there is a point of the form a squared comma a plus 1 is a certain point. And it is known to lie in the angle between the lines. This is one line, this is another line. This is like 3x minus y minus 1 equal to 0 is this line, and minus plus 1, right? Plus 1 equal to 0 is this line, and there is this line which is x plus 2y minus 5 equal to 0 is this line, right? Now, this point a squared and a plus 1, there is origin lying on this side, and the point a squared and a plus 1 lies on the same side as the origin. The point P, a squared and a plus 1 lies on the same side as the origin, right? Containing the origin. right? It's in the same region where the origin is contained. That is what the problem says. The problem says the point of the form a squared and a plus 1 and the origin lie in the same region sandwiched between the two lines. The question is, how should you model A so that this could happen? What should be the range of the values accepted by A so that this could take place? That's the problem. That's the question. Clear? Very simple. It's also based on a very simple idea that we've learned. Look at this line. Look at this line. Origin and this point, they lie on the same side of this line. That means the sign that the origin imparts to this expression must be the same as the sign that a squared and a plus 1 will impart to this expression. Yes or no? Because they lie on the same side of the line, so the origin and a squared a plus 1 will impart the same sign to this expression. What's the sign imparted by the origin? 3 into 0 minus 0 plus 1, which is greater than 0. Right? That means the origin imparts a positive sign. That means on replacing x by a squared and y by a plus 1, this expression must be positive. This expression must be positive. That means 3a squared minus a plus 1 must be greater than 0. Right? 3a squared minus y replaced by a plus 1 must be greater than 0. Right? That means a into 3a minus 1 must be greater than 0. That's equation 1. That's the first condition. Right? So far so good. Now, again, refer to this line, x plus 2y minus 5 equal to 0. Again, the origin and this point, they lie on the same side of this line. That means the sign that the origin produces in this expression must be the same as the sign that this point produces in this expression. What does the origin do to this expression? Put x equal to 0, y equal to 0, less than 0. That means the origin imparts a negative sign to this expression. It becomes minus 5. Right? Therefore, a squared and a plus 1 will also impart a negative sign to this expression. That means a squared plus twice into a plus 1 minus 5 will be less than 0. How about it? Which really means that a squared plus 2a minus 3 will be less than 0. Clear? Now, so my a must be such that it must satisfy condition 1. It must also satisfy condition 2. I need to find values of a commensurate with both 1 and 2. Okay, so now very ordinary algebra. Can I remove the clutter from here and deal with the algebra? Have you all registered the basic idea? Okay, good. Now, wavy curve, if you haven't forgotten that. Now let me look at equation 2, for example. A squared plus 2a minus 3 less than 0. Which means a plus 3 into a minus 1 is less than 0. Now, using wavy curve method, find the range of a minus 3, 1. I hope you haven't forgotten wavy curve. So when will this be less than 0? This will be less than 0 when a belongs to minus 3 to 1. That means this means a belongs to minus 3 to 1 as far as the first condition, this condition is concerned. Right? But that is not just it. And this condition must also be satisfied. That means a into 3a minus 1 must be greater than 0. Dividing by 3, a minus 1/3 must be greater than 0. Now from wavy curve considerations, this is 0, 1/3, this. That means, this really means that a should not belong to 0 to 1/3. A should not belong to 0 to 1/3, right? This means that a can be greater than 1/3 or a is less than 0. A is greater than 1/3 or a is less than 0. Now, So I need to find the intersection of this interval and this interval, these two intervals, right? So systematically speaking, see, the first one produces this minus 3 to 1, right? Minus 3 to 1, right? So whatever be it, and in the interval minus 3 to 1, you need to exclude 0 to 1/3. So 0 to 1/3 to be excluded, because right, 0 to 1/3 is excluded from the description, right? So exclude this 0 to 1/3. No? Intersection of the two conditions. That means A could belong to minus 3 to 0 or 1/3 to 1, right? So A belongs to minus 3 to 0, or is union. Mathematically, or means union. Union 1/3 to 1. If you've forgotten wavy curve, go back to my earlier classes and refer to wavy curve method. This makes sense to all of you? No, not included. If 0 is included, that condition A into A minus 1/3, that will become 0, but that has to be always greater than 0. So if I put A equal to 0, that expression A into A minus 1/3, which should have been greater than 0, will become equal to 0. But that's great. Yes. See, when I put these round brackets, then the endpoints are not included. If I put a square bracket, see, if I put, say, minus 3 and 0, both minus 3 and 0 are included. If I put like minus 3, 0, then minus 3 is excluded, but 0 is included. If I have an interval like minus 3 to 0, then minus 3 is included, but 0 is excluded. So the round brackets will exclude the endpoint. The square bracket would include the endpoint. That's the rule of the game, right? That's the convention. So this is the range of A, minus 3 to 0 and 1/3 to 1. If A belongs to this interval, then the conditions would be successfully met, right? Problem number 5. And listen to me carefully on this. There is a ray of light through a point 2, 1. Say this is a point P, 2, 1. There is a ray of light which is incident at the point A. Oh, on the y-axis, so sorry. So it's on the y-axis. There is a point P, 2, 1. A ray of light starts this way. It's incident at a point A on the y-axis, and after reflection, it passes through a point Q, which is given to be 5, 3. We want to be able to find the coordinates of A. It might seem like a problem of straight lines. It's a problem of geometrical optics. It's actually a problem of geometrical optics. See, you know, whenever light undergoes reflection from a plane surface, it tries to follow a path which takes the shortest time. That means the shortest path is what it follows. Which means, you know, say if there is a light which has to go from a point A to a point B, and this is a mirror. This is a mirror. What it does is, it could have gone this way, isn't it? It could have gone this way. It could have gone this way. There are so many ways it could have paid tribute to the mirror and got reflected and reached B, right? But it chooses only one. In order to reach B, it chooses only one. The one in which angle of incidence is equal to angle of reflection. That is its choice. Reason that is its choice, because See all these paths. See, this is P, P1, this is P2, this is P3. See, the length of this path is AP1 plus P1P. B. The length of this path is AP2 plus P2B. The length of this path is AP3 plus P3B. They have different lengths. Now it will choose a length, total length, which is the shortest. And what we can easily establish is the one which is going to be the shortest from A to B is going to be the following. The one in which angle of incidence becomes equal to angle of reflection. That path is going to be the shortest. That path is going to be the shortest. Why so? I claim that of all the paths from A to B via various P's on the mirror, the one in which angle of incidence is equal to angle of reflection will be the shortest. I claim that. Why so? Okay, one thing. This is A prime, the image of A. This is A prime, the image of A. Object distance will be equal to image distance. AM will be equal to MA prime, etc. Right? And the ray of light reaching the observer B would seem to be coming from A prime. A prime is the image of A. Right? Now, and I claim that this AP plus PB will be the smallest it could be. Look at any other path, say P1. Look at any other path, say AP1 plus P1B. Look at any other path, AP1 plus P1B. Now do you realize that in this path, AP plus PB, right? AP is the same as, look at the path AP plus PB, which is the path that it is meant to follow, right? In which angle of incidence is equal to angle of reflection. AP from congruent triangles will be PA prime, right? A prime P plus PB, right? And A prime P plus PB, right? A prime P plus PB will always be, see again, this AP1 is the same as P1A prime, right? What's the new path? The new path is AP1 plus P1B is the new path, right? But again from congruent triangles, AP1 will turn out to be A prime P1, right? A prime P1 plus P1B, right? So there is this path A prime P plus PB, which is actually A prime B, right? A prime P plus PB, which is actually A prime B. That's one path, total length of one path. And some other path is like AP1 plus P1B, which is the same as A prime P1 plus P1B. Now, A prime B will very clearly be less than A prime P1 plus P1B. Why? Sum of two sides is bigger than the third. So, this path which is AP1 plus P1B, which is the same as A prime P1 plus P1B, is bigger than AP plus PB. AP plus PB, which is equal to AB. AB will obviously be the length of the path in which angle of incidence is equal to angle of reflection, which will be less than A prime P1 plus P1 prime B. Yes or no? So the path in which angle of incidence is equal to angle of reflection is the shortest path that a ray of light could undertake from one point to another, subsequent to getting reflected from the plane mirror. You realize that? That's how nature takes it. If a ray of light following reflection from a plane surface has to go from one point to another, it will do so such that the total length of the path that it undertakes, optical path that it undertakes, is the smallest. And that path would be one in which angle of incidence is equal to angle of reflection. Got me? Now, can I wipe this off? So you must remember this. Can I wipe this portion off? Huh? No, of course not. P I could have selected here. Why should AP be equal to PB? All that it means is AP is PA prime. These two triangles are congruent. Right? You could have taken a point B here. Why should AP be equal to PB? Right? No. Now, okay. And some properties of basic reflection. Object distance is equal to image distance, etc. Now, think of this as a mirror. P as an object, right? And this as an observer. Think of this as an observer. What is the image of P with respect to this? Image of P with respect to the y-axis, do you realize, is going to be minus 2 comma 1? Yes or no? That means Q, who's the observer, would find the object to be here. This is where Q would perceive the image to be, right? That means the image of P, which is P prime, A and Q must be collinear points. P prime, A and Q must be collinear points. Clear? And therefore, if A has coordinates, say 0 comma lambda, because it's a point on the y-axis, right? Collinearity means, now, what's the slope of P prime Q obtained from these 2 points? Lambda minus 1. See, lambda minus 1 by 0 minus minus 2. 2, that's the slope of this, which could also have been obtained using P prime and Q. Using P prime and Q, the slope would be 3 minus 1, 2 divided by 7. Right? Right? So lambda minus 1 will be 4 by 7 or lambda will be 11 by 7. Yes or no? Got me? No? See? Do you realize that as far as Q is concerned, this ray seems to be coming from a point which is the mirror image of P. The mirror image of P about the mirror is minus 2 comma 1. That means minus 2 comma 1, A and Q must be collinear points. What's the slope of the line? Lambda minus 1 by 0 minus minus 2. The slope of the line could also have been obtained by 3 minus 1 divided by 7. So 4 by 7 plus 1, 11 by 7. That's, so A has coordinates 0 comma 11 by 7. Clear? All's good? Yes, you can do it using distance formula. Yes, absolutely. I want you to now mature to reflection principles. You can do it using distance formulas. We will solve some very sophisticated problems in kinematics using laws of reflection, laws of refraction. All of you have read laws of refraction, Snell's law in junior class. So you'll realize once you mature a little more, I'm going to start solving problems in kinematics using laws of refraction, laws of reflection. Reflection principles, refraction principles, they are simply versatile. They are there all over the place and they find applications that you would not even imagine at this point of time, but they will come in very handy to you. But have you registered this basic idea in the first place, right? Shall we proceed then? Okay. Problem number 6. We have a pair of lines passing through the origin, and that pair of lines is given by x squared minus 4xy plus 3y squared equal to 0. Parallel, this is given, minus 4xy plus 3y squared. What we have to find is the one which is not passing through the origin. The one that is not passing through the origin is parallel to this pair. Right? The combined equation of the pair of lines passing through 3 comma minus 2, but parallel to this pair. Parallel to this pair. We are trying to find the equation of this pair. We want to find where if this is the slope of this m1 and m2 is the slope of this, then this is m1 and this is m2. We want to find the combined equation of this pair. Clear? Two ways we could look at it. Two ways we could look at it. One, see, minus 4xy could be written as minus 3xy minus xy. When you factorize this, x minus y into x minus 3y is 0 is what would transpire. When you write minus 4xy as minus xy minus 3xy, then this is what would transpire, right? Are you all right with this? Huh? And which means the two lines are either x minus y equal to 0 and x minus 3y equal to 0 are the two lines here. Right? What? That means this line with slope m1 is parallel to this line. X minus y equal to 0, say. That means this line must be, say, x minus y plus c1 equal to 0 is this line. Right? And this line which is, say, x minus 3y equal to 0, then this line parallel to x minus 3y equal to 0 would be x minus 3y plus c2 equal to 0. What do you say, Nay? If there is a line ax plus by plus c equal to 0, then any line parallel to this line would be, say, ax plus by plus c prime equal to 0. 0 would be any line parallel to this line. So x minus y equal to 0, if that's a line, then any line parallel to this would be x minus y plus c1 equal to 0. Realize the slope of this is 1, the slope of this also is 1. Right? Similarly, if this is a line, then any line parallel to this would be x minus 3y plus c2 equal to 0. Now, can I find the values of c1 and c2? How? Both the lines pass through 3 comma minus 2. So 3 comma minus 2 will satisfy this equation, and 3 comma minus 2 will also satisfy this equation, right? So put x equal to 3, y equal to minus 2. So that will give me c1 equal to minus 5, right? So the equation of this line then becomes x minus y minus 5 equal to 0 is the equation of this line. X equal to 3 and y equal to minus 2 is a point on this line. Put x equal to 3, y equal to minus 2, giving me c1 equal to 5. Now, 3 comma minus 2 is also a point on this line, right? So put x equal to 3, y equal to minus 2. 3 plus 6 plus c2 is 0. X equal to 3, y equal to minus 2. 3 plus 6 giving me c2 equal to minus 9. So that means the equation of this line becomes x minus 3y minus 9 equal to 0. Yes or no? Therefore, one of the lines is x minus y minus 5 equal to 0. This line. The other line is x minus 3y minus 9 equal to 0. The combined equation of these lines is going to be x minus y minus 5 into x minus 3y minus 9 equal to 0 would be the combined equation of the two lines, right? Now you can multiply and simplify matters to get the generalized second degree equation in x and y from the left hand side. You can multiply and get like something into x squared plus something into y squared. You want me to simplify that, or I can leave it at this? You can multiply, right? You can. That's one way to look at it. Is it confusing or is it clear? But I can also give you another way of looking at this problem. Shall I? See, in this case, this had an advantage. I could so readily factorize this. Simple looking factors. And I could get the equation of these two lines passing through the origin, and I could do this. But should I necessarily, having matured to this point, should I necessarily indulge in brute force of this kind? If there isn't a way out, maybe yes, but if there is, I should find something which may not be smaller or larger, but should be more sophisticated than this.
So we can put x minus 3 and y plus 2.
Brilliant, brilliant, absolutely brilliant. Very good. What we could have done is, see, let me tell you the following. Can I wipe this portion off and get to the matter, right? Have you all registered this? Now, see. If you recall my discussions of the previous class, ax squared plus 2hxy plus by squared equal to 0 is a pair of lines passing through the origin having slopes m1 and m2, right? A into x minus alpha whole squared plus 2h into x minus alpha into y minus beta plus b into y minus beta whole squared equal to 0. This pair of lines will have the same slope as this pair, except that this pair would intersect at x equal to alpha, y equal to beta. Both the lines will pass through x equal to alpha and y equal to beta. That means if these two lines had slopes m1 and m2, this has slope m1, this has slope m2. That means this pair will be parallel to this pair, except that it intersects at alpha comma beta instead of 0, 0. Yes or no? So if you want to create a pair parallel to this, but passing through alpha beta, intersecting at alpha beta instead of the origin, then you perform this transformation. Replace x by x minus alpha, y by y minus beta. Have I discussed this form? I started my journey with this, right, and built it up. This is a pair of straight lines parallel to this pair and passing through alpha comma beta. So then, you know what was given was x squared minus 4xy plus 3y squared equal to 0 was the pair of straight lines passing through the origin. What is it that I'm trying to do? I'm trying to create a pair parallel to this pair but passing through 3 comma minus 2. So what all that I need to do is replace x by x minus 3, y by y minus 2. That means y plus 2. That means the required line is going to be x minus 3 whole squared minus 4 into x minus 3 into y plus 2 plus 3 into y plus 2 whole squared equal to 0. In one shot will give me the equation of the lines parallel to this pair but passing through 3 comma minus 2. Has the point been drilled? Right? This is what we could have done, etc. Okay. Number 7. There is a certain line whose equation we want to find. This line will serve as my mirror, right? And there is a point A minus 2 comma 6. And it's the image of a point B. It's the image of a point B with coordinates 4 comma 2. Image of a point B with coordinates 4 comma 2 with respect to this line. I want to be able to find the equation of this line. Very simple. If A and B are mirror images of each other, then the midpoint of this must lie on the mirror, right? What's the midpoint of this? 1 comma 4 is the midpoint, isn't it? 4 minus 2 by 2 and 6 plus 2 by 2. That's the midpoint. This is a point on the required line. Now, what's the slope of AB? The slope of AB is 4 divided by minus 6. Minus 2 by 3 is the slope of AB, isn't it? So what's the slope of the required line? The slope of the required line will be 3 by 2 because the line joining the image and the object is perpendicular to the mirror. So the slope of this 6 minus 2, 4 divided by minus 6. That means minus 2 by 3 is the slope of this. Slope of this therefore will be 3 by 2. So can you not find the equation of this? The equation of this is going to be y minus 4 is 3 by 2 into x minus 1 etc. would be the equation. So you can simplify this, and that's going to give you the equation of the required line. What's the answer? C? Okay. Okay. So problem 7, C then. Simple, isn't it? There is a line segment AB which is essentially y equal to x, right? Oh, sorry, again I did this. Oh, shit. I'm biased. Number 8. There is a point minus 3 comma 4. Minus 3 comma 4 is a point here. Yes, absolutely. But let's still do it. Minus 3 comma 4 and reaches, man starts from P and reaches a point Q which is 0 comma 1 after having paid tribute to a point R on the x-axis. This is what he does. Now, this guy is in a rush to reach Q. There is a gold mine at Q. He wants to reach Q very, very soon, right? So he must decide his direction PR. That means he must model his point R on the x-axis. That will cause him to have the shortest distance PR plus RQ. Fortunately, he knew some physics. He knew about light. So he said, I must follow the dictation of light. I must move in a manner that PR becomes like an incident ray and RQ is reflected ray. That means RQ is the reflected ray such that angle of incidence is equal to angle of reflection. This is what must happen. So it's as if there is a ray of light that starts from P. This is an incident ray. This then is a reflected ray. This is what he must do. That means if P is an object, this is the observer, this is the observer. How should he do this? Now, there is also a principle in light called the principle of reversibility of light. So if there is a ray of light that starts at Q, then after reflection it will reach P. That's principle of reversibility of light. Which means if Q is an object, and this is an observer, and this is the mirror, then the image of Q about the x-axis would be Q prime 0 comma minus 1. Right? That means if P is an observer and Q is an object, then the image of Q is Q prime, which means this. That means P, R and Q prime must be collinear points. P, R and Q prime must be collinear points. Yes or no? Right? So if R has coordinates lambda comma 0, if R has coordinates lambda comma 0, now what's the slope of this? 4 minus minus 1, which is 5, divided by minus 3. That's the slope of this line. Could also have been obtained using lambda 0 and 0 comma minus 1. So that's equal to lambda divided by 1. Lambda therefore is minus 5 by 3. Have I made a mistake? Minus 3 by 5? No. So this is 5 divided by minus 3. That's the slope of this. This is, oh sorry, 1 by lambda. This is 1 by lambda. I'm so sorry. 0 minus minus 1 divided by lambda. So 1 by lambda. Lambda therefore is minus 3 by 5. So this point R has coordinates minus 3 by 5 comma 0. Yes, you have a question. Absolutely. Only issue is if instead of using the x-axis, if I had some other line, then yes. No, he has to pick the keys from a point located at R. There is a door to the gold mine there. He has to pick the keys from some point on the x-axis. So he has an agent who's running around here and he needs instruction where to keep the key on the x-axis. So then this guy says, oh, I know geometrical optics, keep it at R. That's all. Got me? Can I wipe this off?
If you had brains, you would have said keep it at Q.
Huh?
Keep it at Q.
What?
His treasure.
Hurry.
His treasure.
It's not his treasure. No. Who would keep it at Q?
The one who had kept it at R.
Huh? This guy. Now this guy is handicapped. He can't move to Q. Come on. Let's not care about brains. Let's also care about, the limitations. All right? Can I wipe this off? Problem number 9. There is a line segment AB which is part of the line y equal to x, which is part of a line y equal to x. And there is a mirror which is 2x minus y minus 1 equal to 0 is a mirror. All right. I want to be able to find the reflection of AB, the image of AB about this mirror, A prime, B prime. I want to be able to find the reflection of AB about this mirror. You know what I'm saying? AB is a segment and this is a mirror, right? This is an object. If this is an object, I want to find its image A prime, B prime, where this is the mirror. This is an object. 2x minus y minus 1 equal to 0 is a mirror. I want to find its image A prime, B prime. Right? Okay. Now, any point on this line, for example, let me find the image of any point on this line. Say there is a point P, any point on this line would have coordinates h comma h, isn't it? Because y is equal to x for all points on this line. So any point, so all that I need to do is I need to find the image of P, h comma h, which is any point on this line, right? So which means if there is a point h comma h and there is a mirror which is, this is the point P, the mirror which is 2x minus y minus 1 equal to 0 is a mirror, then the image of P is P prime. Let's say that has coordinates x comma y. That has coordinates x comma y. Right? Now, if you recall a result which I discussed in the class, x minus h divided by a, which is 2, is y minus h divided by minus 1 is equal to 2h minus, well, minus 2 times, replace x by h, y by h, and divide by 2 square plus 1 squared. Recall that result? So minus 2 times 2h minus h minus 1 divided by 2 square plus 1 squared, 5. Yes or no? Recall this? Where xy is a point on the, any point on the reflected body, right? Reflection of AB. Reflection of AB. P prime is any point on this. P prime is any point on this reflected image, right? So I need to find the equation of this. That means I need to find a relationship connecting the x and the y coordinates of any point on this. The equation of this would be what? A relationship that's going to connect the x and the y coordinates of this point P prime. That'll give me the equation of the image of AB, right? So now from these two, see, this realize is this is h minus 1, so minus 2 by 5 into h minus 1, right? So this gives me x equal to h minus 4 by 5 into h minus 1, right? So 5x equal to h plus 4, right? See, 5x equal to 5h minus 4h, h plus 4, that's out of this equation. Now as far as y is concerned, y minus h, y equal to h plus 2 by 5 into h minus 1, right? So that gives me 5y equal to 7h minus 2. Yes or no? So I need to connect x and y. What's my parameter? H comma h, which is a point on y equal to x. I need to eliminate h, my parameter, connect x and y. That's going to give me the equation of the image, right? So equation 2, 5y equal to 7 times h. H is what? 5x minus 4? Minus 2. See? 5y equal to 7h. 7h means 7 into 5x minus 4 minus 2. This will give me the equation of the image. Yes or no? Clear? Lost? I'll explain again. Okay. This is the mirror, which is 2x minus y minus 1 equal to 0. This is a line y equal to x. I want to find the equation of the image of this about the line 2x minus y minus 1 equal to 0. I take any point on y equal to x, which must be of the form h comma h. Let's say its image is x comma y. Then from a result that I have discussed in the class, x minus h by 2, x minus h divided by 2 equals y minus k, which is h, divided by minus 1 equals minus 2 times, replace x by h, y by k. So 2h minus h minus 1 divided by 2 square plus 1 square. This is a formula that I have derived for you in the class. So this gives me x equal to minus 4 by 5. See, x equal to minus 4 by 5, h minus 1 plus h. From these two I get x equal to this. So I get 5x equal to 5h minus 4h, h plus 4 is what I get. Now from these two I get y minus h, y equal to h plus minus 2 by 5 into h minus 1, right? So plus, so that gives me 7h minus 1 minus 2 equals 5y. I need to eliminate h. In this 5y equal to 7h minus 2, I replace h by 5x minus 4. So 5y equal to 7 times h, which is 5x minus 4 minus 2, right? So that gives me 5y equal to 35x minus 30, y equal to 7x minus 6. That's the equation of the image. That's the equation of the image. Yes or no? It's about a condition. A by root BC minus 2 equals root B by C plus root C by B, where A, B, C are all positive entities, positive real numbers. A, B, C could all be varied. A, B, C could all be varied. But they're varied subject to this condition. At all times, your choice of A, B, C must be commensurate with this condition. Right? So they're not wild parameters. They can't just take any and every value. The values that they will assume must satisfy this condition. Right? Therefore, with every ABC that satisfies this condition, with every ABC that satisfies this condition, you could have constructed a line like this. Root A into x plus root B into y plus root C equal to 0 is a line that could have been constructed out of an ABC commensurate with this. So there is a family of lines associated with this, right? We need to check if the family of lines pass through a common point or not. Whether this family of lines is concurrent or not is what we need to check. All the lines obtained out of this choice of ABC, whether they are concurrent or not, is a check that we need to perform. Clear? Now, there is some algebra here. There is some algebra here. What I do is I multiply by root BC throughout, right? If I multiply by root BC throughout, I end up getting A minus 2 root BC equals root B, or rather B plus C is what I get. Or I end up getting A equals root B plus root C whole square. Right? Or I end up getting root B plus root C equals root A. Not negative, because root B is always non-negative, root C is always non-negative. So I couldn't have had this as minus root A. Minus root A would have been a negative number. Right? So that's not acceptable. Okay. Which means now I could write that condition as minus root A plus root B plus root C equal to 0. Right? This I could have rewritten as root A into x, which is minus 1, plus root B 1 plus root C equal to 0. Yes or no? That means this line passes through minus 1 comma 1 always. See? This is like root A into x plus root B into y plus root C equal to 0. That means this line will always pass through a point x equal to minus 1, y equal to 1. Yes or no? For every appropriate selection of A, B and C, that means appropriate means one that satisfies this condition is an appropriate ABC. You could have constructed lines of this kind. All these lines then would pass through minus 1 comma 1. See? On comparing this, root A x plus root B y plus root C equal to 0. And what I get out of this condition is root A into minus 1 plus root B into 1 plus root C equal to 0. That means this line. Okay, now if I ask you a question, will minus 1 comma 1 be a point on this line? Yes, because if you plug in x equal to minus 1, y equal to 1, you get this, which indeed is 0. So minus 1 comma 1 will always be a point on this line. That means all lines constituted thus will be a bunch of concurrent lines, and they pass through a point, common point P, which is minus 1 comma 1. Yes or no? So this family of lines are concurrent lines, and they pass through a common point minus 1 comma 1. Is that okay or not okay? Is about the perpendiculars from 3 points onto a line. There is a line x plus y tan theta plus tan square theta equal to 0 is a certain line, right? And we are seeking perpendiculars from 3 points, a squared comma 2a. The perpendicular from this point onto this line is referred to as P1. Then there is a point AB comma a plus b. The perpendicular from this point onto this line is referred to as P2. And then we are talking of b squared comma 2b. The perpendicular from this point onto this line is referred to as P3. Yes or no? We want to figure out whether P1, P2, P3 are in AP, GP, HP, etc. Right? Now, what is P1? Perpendicular distance of this point from this line. Right? Means it's going to be magnitude of replacing x by a square, y by 2a, plus tan square theta divided by root 1 plus tan square theta, which is mod sec theta. Root 1 plus tan square theta, right? 1 square plus tan square theta, which is mod sec theta. Which is, this is a plus tan theta whole square, isn't it? This is a plus tan theta whole square. Mod of sec theta. That's as far as P1 is concerned. Now, P3 is simply replacing a by b. P3 is simply replacing a by b. So very clearly, P3 is going to be mod b plus tan theta whole square divided by mod sec theta right? And P2 is the perpendicular distance of this point from this line, right? So P2 is mod of AB plus A plus B tan theta plus tan square theta divided by mod sec theta. That's as far as P2 is concerned, right? What is this? This is mod of A plus tan theta into B plus tan theta. Yes or no? Divided by mod of sec theta. Is it not? Right? Very clearly, you can see from P1, P3 and P2, P1 into P3 is very clearly P2 squared, right? When you square this, you get P1 into P3. Do you see that? This is P3, this is P1, P1, P3 must be equal to P2 squared. That means P1, P2, P3 must be in GP. P1, P2, P3 must be in GP. I expected you to get this right. Right? All of you got this right? Okay. Arithmetico-geometric progression. Say x plus 2x squared plus 3x cubed, for example. You know, 1, 2, 3 are in AP, whereas x squared, x cubed, etc. are in GP. So this is a hybrid series called arithmetico-geometric progression, AGP, right? ABC is a variable triangle such that A is 1, 2, A is say 1, 2, B and C lie on the line y equal to x plus lambda, where lambda is a parameter. Lambda is a parameter. So B and C are moving points, A is a fixed point. If lambda is varied, the coordinates of B and C will vary, right? The locus of the orthocenter of triangle ABC. Locus of the orthocenter of triangle ABC. Is there anyone who got this right? Okay. Orthocenter of triangle ABC. What would that be? Very simple. Say, this is the altitude from A on to BC, right? The slope of the line joining A and H will always have slope -1. Why? Because the slope of BC is 1. So slope of AH would always be -1, right? Which means if at any given instant of time x comma y be the coordinates of H, right? Then y minus 2 by x minus 1 will always be -1, right? No matter what lambda is, no matter what lambda is. So y minus 2 by x minus 1 is -1. So that gives me x plus y minus 1 is 0 is the locus of the orthocenter of the triangle. For any given lambda, say the coordinates are x comma y, coordinates of H are x comma y, then this AD will always be perpendicular to BC. AD will always be perpendicular to BC. Now this is actually family of parallel lines having slope 1. So all the BCs produced would have slope 1, and therefore all the ADs at all times will have slope -1. Yes.
Yes, -3. X plus y minus 3 equals to 0.
Oh, -3. Sorry. X plus y minus 3 equal to 0. Right. So if at any given instant of time the orthocenter has coordinates x comma y, then y minus 2 by x minus 1 will be the slope of this, right? So which is minus 1, which is minus 1. So that gives me x plus y minus 3 equal to 0, which is an algebraic relationship connecting the x and y coordinates of the orthocenter H. This therefore must be the locus of H. So option B. Option B. So why could you not solve this? What did you do, Abib sir? Same thing? Same thing, right? Oh, you started thinking too much, right? Right. So there is a range within which you must think. It should not fall below the lower end of the interval. It should not go more than the upper end of the interval. Otherwise, you mess it up, right? And it's for you to figure out what's an appropriate range, right? Okay. Right. But it was actually a very easy problem, isn't it? Okay, let's move on to the next problem. Can I wipe this off? There is a line 2x plus y minus 4 equal to 0. 2x plus y equal to 4 is this line. That means x by 2 plus y by 4 equal to 1 is the equation of the line, right? So it meets the x-axis at A. So A must have coordinates 2, 0 and B must have coordinates 0, 4, right? The perpendicular bisector of AB meets the horizontal line through 0, minus 1. This is the perpendicular bisector of AB. This is the perpendicular bisector of AB. Perpendicular and D is the midpoint. What would be the coordinates of D? 1, 2 would be the coordinates of D because it's the midpoint of AB, right? The perpendicular bisector of AB meets the horizontal line through 0, minus 1. This is a horizontal line through 0, minus 1. This is a point 0, minus 1. This line would have equation y equal to minus 1 would be the equation of this line. Meets it at C, right? G be the centroid of triangle ABC. We want to find the perpendicular distance of G to AB. From G, the centroid, we want to find the distance from AB. Very simple. C, realize if G is the centroid somewhere here, G is the centroid somewhere here, C would have x coordinate say x1 and its y coordinate would be minus 1, right? What's the slope of this? Slope of this line is minus 2, isn't it? The slope of this line is minus 2. So the slope of CD would be half. Slope of this is minus 2. So the slope of CD would be half. Now that gives me an opportunity to obtain x1, the coordinates of C. So then we have 3 divided by 1 minus x1, isn't it? That's the slope of this. 2 minus minus 1 divided by 1 minus x1, that's the slope, and that's equal to half. So 1 minus x1 is 6 or x1 is minus 5, right? So the coordinates of C would be minus 5, minus 1 would be the coordinates of C. Yes or no? Now, this is the line 2x plus y minus 4 equal to 0. D being the midpoint of AB, CD is a median. CD is a median. So G must lie on this median, right? Now can I find the distance of C from AB? How do I find? That means distance of minus 5 minus 1 from this line is going to be what? Distance of minus 5 minus 1 from this line. Replace x by minus 5, y by minus 1 and divide by root 5, right? So minus 5 minus 11 minus 15 divided by root 5. Am I right? See? Minus 10 minus 11 minus 4. 15 by root 5, yes or no? Right? So 15 by root 5 is what? CD is CD, right? 15 by root 5 is CD. This GD is 1/3 of CD, isn't it? GD would be 1/3 of CD. So GD would be 1/3 of 15 by root 5. 5 by root 5 means root 5. Yes or no? All of you got this right? How many of you got this right? 1, 2, 3. Same answer? Okay. Very nice. Let's look at 14. So far so good, right? Not a problem? Rajashri? Sure now? CD? Perpendicular distance of a point from a line. This is the line 2x plus y minus 4. What is its perpendicular distance from a point minus 5 comma minus 1? Replace x by minus 5, y by minus 1. Take the modulus of this, divide by root 2 square plus 1 square. So minus 10, minus 11, minus 4, 15 by root 5. Got it? The centroid divides a median in the ratio 2:1. Right? This is 2:1. That means this must be 1/3 the median. This must be 2/3 the median. Right? No? Let's look at 14. Can I wipe this off? Are you okay with this, dude? Sure? So there is a point A, 1 comma 2. There is a point A, 1 comma 2. And y equal to, and there is BC. ABC is a triangle. This is the perpendicular bisector of AB, and this is y equal to x. D. D is the midpoint of AB, and this is perpendicular to AB. So perpendicular bisector of AB, and this is the line y equal to x, right? If the equation of BC is x minus 2y plus 1 equal to 0, plus 1 equal to 0, oh, is the angle bisector at C, sorry, is the angle bisector at C. This is the angle bisector at C. This is the angle bisector at C, and the equation of the angle bisector at C is given to be x minus 2y plus 1 equal to 0. We need to find the equation of this. If the equation of this is ax plus by minus 5 equal to 0, we want to be able to find the values of a and a plus b. We want to be able to find the value of a plus b. Do you realize that? So y equal to x is the perpendicular bisector of AB. That's one. X minus 2y plus 1 equal to 0 is the internal angle bisector at C. And ax plus by minus 5 equal to 0 is the equation of BC. And we want to be able to find the values of value of a plus b. Is there anyone who solved this problem right? No one? No one solved this right? Okay. But you have attempted this, right? So one thing. About the line, since y equal to x is the perpendicular bisector of AB, can I say that A and B are mirror images of each other about y equal to x? Can I say that? A and B are mirror images of each other about y equal to x? That means if A has coordinates 1 comma 2, what would be the coordinates of B? 2 comma 1. Now a result which I gave to you in one of the classes. If this is an angle bisector at C, then the mirror image of A about this line must lie on BC. Do you recall that result? Do you recall that result? If this is an internal angle bisector at C, then the mirror image of A about the internal angle bisector must lie on BC. Recall that? Okay. So this is the line x minus 2y plus 1 equal to 0. Let me find the mirror image of A. This is A, which is 1 comma 2. And this is the line x minus 2y plus 1 equal to 0. And I claim that the mirror image of A about this line, call it E. This E must lie on BC. This E must lie on BC. I mentioned this result. I mentioned this result in the class, right? So all that you need to do is find E, the mirror image of A about this line, right? How do you do that? So E suppose has coordinates x comma y. Then we have x minus 1 divided by 1 equals y minus 2 divided by minus 2, right? Right? Equals minus 2 times, put x equal to 1 and y equal to 2. So 2 minus 4 minus 2 divided by 5. Yes or no? Putting x equal to 1, 1 plus 1, 2 minus 4 minus 2 divide by 5. Do you all understand this? What? This is a formula. If you have forgotten this, obviously you will not understand this. This is a result that I gave in the class. So this is 4 by 5. So which means x minus 1 by 1 is 4 by 5. So x then becomes 9 by 5. 1 plus 4 by 5, 9 by 5. Then y becomes 2 minus 8 by 5. Isn't it? See? 8 by 5 minus 8 by 5 plus 2. Isn't it? So 2 by 5 is y? Yes or no? See, from this and this. Y minus 2 is minus 8 by 5. So y would be 2 minus 8 by 5, which is 2 by 5. That means there is a point E on BC having coordinates 9 by 5 comma 2 by 5. So 9 by 5 comma 2 by 5 will satisfy this equation. You'll be able to solve, you'll be able to find the equation then. No? This is supposed to be no, this is supposed to be yes. What is it that you want to say? No, didn't understand. Understand. Very good, understand. Shall we proceed? Confused? Okay. Let's look at 15. Let's look at 15. I mean, in the sense, you know E and B, you can find the equation of this line, isn't it? And if you know the equation of this line, then you know A and B, and you can find A plus B, right? So can I leave it at this point? Right. Pradyum, Babaji, understand? See, what you don't understand is that he thinks in a different astral plane. All right. So what I might try to communicate, what seems beyond his reach is actually his mental strength, which is like he is beyond that. It's about he being beyond that. That's why sometimes he doesn't register that. Huh? No, that's an understatement. Look upon him with awe and respect. Okay? Shall we move? Have you all understood everything that I have communicated in this? Huh? Number 15. Anyone who solved 15? Huh? You solved 15? Anyone else who solved 15? Who all solved 15? 1, 2, 3, 4. Very good. You didn't solve 15? Okay. 1, 0 is the center of a circle of the incircle of triangle ABC. This is I. I is 1 comma 0, the incenter of the triangle for certain triangle ABC. The equation of BI is x minus 1 equal to 0. What is the line x minus 1 equal to 0? This is the line x minus 1 equal to 0. X equal to 1, right? X minus 1 equal to 0 is this line, x equal to 1. B lies on this line. B lies on this line, right? An equation of Ci is x minus y minus 1 equal to 0. That means C passes through this. C must lie somewhere on this. Ci is x minus y minus 1 equal to 0 is the equation of Ci. C must lie somewhere on this, right? We now want to find the angle BAC, right? So C, let's say, lies somewhere here, right? The equation of Ci is this. Let's say B lies somewhere here, and A lies somewhere here, say. I want to be able to find this angle A. I want to be able to find this angle A, right? See, what's the slope of this line? 1. Slope of this line is 1. What's the angle, therefore, that this will make with the positive direction of the x-axis? 45 degrees. This is 45 degrees. That means angle BIC, see in this triangle, ABC, where I is the in center, what is this entire angle equal to? Pi by 4 plus 90 degrees, 3 pi by 4. This entire angle will be 3 pi by 4. Yes or no? Pi by 4 plus pi by 2, right? This is 90 degrees plus pi by 4. That makes it 3 pi by 4. That means BIC is 3 pi by 4. Right? Now, this is B by 2, right? BI will be an internal angle bisector if I is the in center. CI will be an internal angle bisector at C. This is C by 2, this is B by 2, right? So, B plus C by 2 is sum of these angles, which must be pi minus 3 pi by 4. Isn't it? This is B by 2 plus C by 2. That must be pi minus 3 pi by 4. Which is pi by 4. That means B plus C must be pi by 2. A therefore is pi minus B plus C, which is pi by 2. Got it? Let's look at 16. Is there room for confusion? See, the line joining the vertex to the in center would be an internal angle bisector. So this would be B by 2, this would be C by 2, right? So this plus this is B plus C by 2, which is pi minus 3 pi by 4, which is pi by 4. So B plus C is pi by 2. So A therefore, which is pi minus B plus C by 2, pi minus B plus C, which is pi by 2. That's A. Therefore, this angle is 90 degrees. Right? Three of us. Anyone else who got 16 right? Okay. So then listen to me. This is based on geometry that you learnt in class 7. Long time, from 7 to 11, right? Okay. 16. There is a line 3x minus 2y minus 12 equal to 0, right? This could have been written as x by 4 plus y by minus 6 equal to 1 is this line. Let me just draw this line. is this line. See, this is A, this is B. Right? This is this line. And then there is a line x plus ky plus 3 equal to 0. Right? That line is like x by minus 3 plus y by minus 3 by k equal to 1. Now this second line has an x-intercept minus 3, 0. Second line passes through minus 3, 0. And its intercept on the y-axis could be positive or negative depending on the sign of k. Depending on the sign of k. Right? Now, suppose k is negative, then its y-intercept would be positive. Suppose k is negative, then its y-intercept is positive, in which case the line would look like this with its y-intercept being d. With its y-intercept being d. If k is negative, then its y-intercept would be d on the positive y-axis. Now, so that's one possibility, that the 4 points are concyclic. Now, it's essentially, see, these are the 4 points, you want them to be concyclic. And we have AC like this, and we have BD like this. AC like this, BD like this. These are the two chords, right? These are the two chords, and these 4 points are concyclic, means they lie on the same circle. Now, a result that you studied in junior class, PA into PC must be equal to PB into PD. Yes or no? PA into PC must be PB into PD. That means one of the possibilities is, this is my point P. This is 4 units, this is 3 units, so this is 12 units, right? That must be equal to, now this is 6 units, so therefore this must be 2 units. This must be 2 units. For some k, this length will become 2 units. That will happen if minus 3 by k is 2. That will happen if minus 3 by k is 2. That's a y-intercept, right? That's one possibility. So for one particular value of k where its y-intercept minus 3 by k is 2 units, that means k equal to minus 3 by 2, the 4 points will be rendered concyclic, right? That's one case, right? The other case is, so one value of k is guaranteed, which will cause the 4 points to be concyclic. This value of k equal to minus 3 by 2. The other possibility is the following. Can I wipe this off? For a certain value of k, minus 3 by k could be negative. And when that happens, this of course is AB. A is 4, 0. B is 0 comma minus 6. C of course is minus 3, 0. Now, if D coincides with B, then do you realize ABCD would be concyclic points? Because now it's a triangle. ABCD with B coinciding with D would become a triangle, right? Would become a triangle. And then every triangle, you know, the 3 points, there is a circle that will determine. There is a circle that will uniquely pass through A, B, C and D, right? Then of course the 4 points would be once again concyclic. That will happen when minus 3 by k, is minus 6. So that will give me another value of k. So essentially there are 2 possible geometric configurations leading to 2 distinct values of k that will cause ABCD to be concyclic points. Is that okay? Right? There is no other geometric configuration for this situation that will cause ABCD to be concyclic points. Are you all okay with this? This is the case where B and D coincide. That means minus 3 by k is minus 6. It's essentially 2 points B and D degenerating into 1 point, causing ABCD to be essentially a triangle, and the 4 points would always be concyclic because you can always find a circle passing through the 3 points. Shall we proceed then? OABC is a rectangle with OA being 3 units, OC being 4 units, AD being 1.5 units, AD is 1.5 units. We want to be able to find the slope of the diagonal OB. We want to be able to find the slope of the diagonal OB. Clear? Now, this is 4 units, this is 3 units, right? Suppose this angle is alpha, then what is tan alpha equal to? What is tan alpha equal to? 3 by 4? Suppose this angle is beta. What is tan beta equal to? 1.5 by 3, that is half, right? Suppose this angle is theta. Then do you realize theta is pi by 2 minus alpha plus beta? Yes or no? Theta is pi by 2 minus alpha plus beta. Is it not? Tan theta is the slope. Right? Tan theta is the slope. So tan theta is tan 90 minus alpha plus beta, which is cot alpha plus beta. Right? Which is 1 minus tan alpha tan beta divided by tan alpha plus tan beta. Tan alpha you know, tan beta you know, you can plug into this and get the slope tan theta of the diagonal OB. ABC is a right angle triangle. This is A, this is C, and this is B. This is a right angle triangle. That's given. This length is given to be 3 units. This length is given to be 4 units. This obviously is 5 units at all times. AC is sliding along the coordinate axis. AC is sliding along the coordinate axis. And imagine this ABC to be a wireframe. Imagine this ABC to be a wireframe. So that if you imagine this to be a wireframe, the relative separations between AB and C in pairs would remain the same. You know what I'm saying? So while AC slides, B also moves. So there is a locus associated with B. There is a locus associated with B. Now we want to be able to find the locus of B. That means the straight line on which B will always lie. Right? There is a certain straight line on which B will always lie, which is essentially the locus of B. See, can you think of a circle passing through AB and C? Yes. Any triangle, there is a circumcircle of triangle ABC, and its diameter will be AC. Why? Because this is angle in a semicircle. Right? If there is a circle passing through AB and C, AC will be the diameter of that circle. Right? Now, if this is O, the circle that passes through AB and C will also pass through O. Why? Because if this plus this is 90 degrees, then at all times OABC will be a cyclic quadrilateral. OABC will always be a cyclic quadrilateral because this remains 90 degrees, this anyways is 90 degrees. So the circle that passes through AB and C will also pass through O. The circle that passes through AB and C will also pass through O, right? Yes or no? Now, This is always a cyclic quadrilateral. No matter where B moves, this quadrilateral will always be cyclic. OABC will be a cyclic quadrilateral. Now, if this angle is theta, this will also be theta. Angles in the same segment. Angles in the same segment. Now, what is tan theta from this triangle? 3/4 is tan theta. Right? The slope of this OB, slope of OB will always be tan alpha. Which is tan 90 minus theta. Alpha is 90 minus theta. Which is cot theta. Which is 4/3. Yes or no? So B will always be a point on a line passing through the origin and having slope 4/3. Slope of OB turns out to be 4/3. So what's the equation of OB? Equation of OB is y equal to slope 4/3 into x. So B will always lie on this line. So B lies on the line 3y equal to 4x. Yes or no? Y equal to mx. Bothersome or is it all right? So B will always lie on this line passing through the origin 3y equal to 4x. Clear? How many of you got this right? Didn't attempt? Brute force. Let's look at 20. So there is a pair of straight lines, ax squared plus 2hxy plus by squared equal to 0 is a pair of straight lines. That's given. This is one line. This is the other line. This represents a pair of straight lines passing through the origin. These are the two lines, say. And one of the angle bisectors between this pair is given to be y equal to x. So this is one line with slope m1. This is the other line with slope m2. Right? This is one of the angle bisectors between this pair. This is given to be y equal to x. Is given to be y equal to x. Now, suppose this is, say, this angle is theta, then this will also be theta, right? This will be 45 degrees because this is the line y equal to x. It makes an angle 45 degrees with the positive direction of the x-axis. This is 45 degrees. Yes or no? Okay. Now m1, this angle, say theta 1, this angle that this line makes with the positive direction of the x-axis is going to be pi/4 minus theta 1. Yes or no? Sorry, minus theta, right? This theta 1 is going to be pi/4 minus theta, right? And this angle, theta 2, tan theta 2 is the slope of the other line, is going to be what? Theta 2 is going to be pi/4 plus theta, where tan theta 1 is going to be the slope of one of the lines, tan theta 2 is going to be the slope of the other line. Yes or no? Now, do you realize theta 1 and theta 2 are complementary? Because theta 1 plus theta 2 is pi/2 if you add these two. Theta 1 plus theta 2 is pi/2. See, theta 1 plus theta 2 is pi/2. Are you lost somewhere here? You missed out on any of these entities here? All of you okay? So now, theta 1 therefore is pi by 2 minus theta 2. If I take the tan of both sides, then tan theta 1 is cot theta 2. That means tan theta 1 into tan theta 2 is 1. That means product of their slopes is 1. M1, M2 is 1. Hey, but what is M1, M2? Product of the slopes A by B, isn't it? A by B will give me product of the slopes of the two lines here, A by B, right? That means A by B is 1. That gives me A minus B equal to 0. So we have a variable triangle. This is a triangle whose one vertex is fixed. Call it 3, 4. One vertex is B. Call it 5 cos theta, 5 sin theta. One vertex is C, which is 5 sin theta minus 5 cos theta. Now, why is this variable? It's variable because theta is varying. Theta is a parameter. Vertex C is of the form 5 sin theta minus 5 cos theta. B is of the form 5 cos theta, 5 sin theta. A is the only fixed point of this triangle. So while theta is varied, the points B and C will move, right? And therefore, that will cause the triangle to be a variable triangle, right? Now, if this triangle is varied, then obviously its orthocenter will also vary. Its orthocenter will also vary in position. There is then a locus associated with the orthocenter. We wish to find the locus of the orthocenter of this variable triangle. Yes or no? Right? Now, few simple observations. Few simple observations. One, what is the distance of 0, 0 from A? 5 units. Yes or no? Root 3 square plus 4 square. What's the distance of 0, 0 from B? Distance formula? Root 5 cos theta whole squared plus 5 sin theta whole squared. So that makes it 25 cos square theta plus sin square theta. That makes it 5. Distance of O from B is also 5. Then what's the distance of C from O? Same, 5, isn't it? Root 5 sin theta whole square plus minus 5 cos theta whole square, right? So that makes it also 5. That means O is equidistant from the vertices of the triangle, right? That means with O as the center and OA, OB or OC as the radius, you could draw a circle passing through AB and C. That means O must be the circumcenter of triangle ABC. Therefore, the circumcenter of this triangle is the origin, right? Okay. At all times, the circumcenter will not vary. At all times, the circumcenter will not vary. Even though B and C will vary, the circumcenter of the triangle will remain 0, 0. The circumcenter. This is the circumcenter. Now, this is the centroid and there is this orthocenter. Did I tell you a result? Did I tell you a result that the orthocenter, the centroid and the circumcenter will always be collinear points? Have I shared that with you? Right. Now, what is the centroid of the triangle? The centroid of the triangle would be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. That's a centroid. So the centroid has coordinates 3 plus 5 cos theta plus 5 sin theta by 3, right? X coordinate 3 plus 5 cos theta plus 5 sin theta by 3 would be the x coordinate of the centroid, right? The y coordinate of the centroid is going to be 4 plus 5 sin theta minus 5 cos theta by 3. That will be the y coordinate of the centroid. So that's 4 plus 5 sine theta minus 5 cos theta by 3. That's the centroid. Now, if the orthocenter is h comma k, and I'm seeking to find the locus of h, the orthocenter of the triangle, that means what am I trying to connect? I'm trying to connect the x coordinate h with the y coordinate k of the orthocenter by eliminating theta, the parameter. And then we go ahead and generalize, replace h by x and k by y, right? Now, the centroid divides the line joining the orthocenter and the circumcenter in the ratio 2:1. Yes or no? Right? So then in terms of hk, what's the centroid? 2 into 0 plus 1 into h by 3. What's the y coordinate of the centroid? 2 into 0 plus 1 into k by 3. Yes or no? Right? That means this must be h by 3 and this must be k by 3. Yes or no? So h by 3 is equal to the x coordinate of the centroid, 3 plus 5 cos theta plus 5 sine theta by 3. That's the x coordinate of the centroid. The y coordinate of the centroid, k by 3, is equal to 4 plus 5 sine theta minus 5 cos theta by 3. That's the y coordinate of the centroid. Right? Yes or no? Now, if I add these two, then I end up getting, so I need to eliminate theta, right? So if I can solve for cos theta and sin theta and square and add, then theta gets eliminated. So one way to do that is h plus k equals 7 plus 10 sin theta, 10 cos theta, beg your pardon. Oh, sorry, 10 sin theta, sorry, 10 sin theta, right? If I subtract, then I end up getting h minus k equals minus 1 plus 10 cos theta. On subtracting these two equations, this is what I get. That means h plus k minus 7 is 10 sin theta. From this equation, h minus k plus 1 is 10 cos theta. How do I eliminate theta from here? I square and add. So when I square and add these two, then I end up getting h plus k minus 7 whole squared plus h minus k plus 1 whole squared is 100 cos square theta plus sin square theta. And then, so we have a relationship that connects the x coordinate h with the y coordinate k of the orthocenter of the proposed variable triangle. Generalize that, replace h by x and k by y to get the required locus. That means x plus y minus 7 whole squared plus x minus y plus 1 whole squared is 100. Got me? That's the locus of the orthocenter of this variable triangle. Make sense to all of you? Right? Let's move on to the next problem. So option D, right? X plus y minus 7 whole squared plus x minus y plus 1 whole squared is 100. Option D is correct. Clear? How many of you worked on this problem and got it right? No one. No one worked on it at home. Didn't get it right. Okay. Never mind. Can I wipe this off? So, in problem 22, there is a triangle OAB. O is the origin, 0, 0. B is a point, 3, 4. B is a point here, 3, 4. A is some point, we do not know where it is. But the orthocenter of the triangle is 1, 4. Orthocenter of the triangle is 1, 4. Okay. See, that means the orthocenter and B have the same y coordinate. That means orthocenter H is somewhere here, 1, 4. That means the line joining one vertex with the orthocenter must be parallel to the x-axis because they have the same y coordinate. H and B have the same y coordinate. Yes or no? Therefore, this line must be like y equal to 4. This line must be y equal to 4 parallel to the x-axis. That's where. Okay. Which means the line joining B and H must be perpendicular to the third side. Must be perpendicular to the side opposite B. Because, right, if you join a vertex to the orthocenter, it will be perpendicular to the opposite side, side opposite B. Now this line is perpendicular to the y-axis. That means the y-axis must be the side opposite to B. That means A must lie somewhere here. That means A must lie somewhere here, yes or no? And if A lies somewhere here, that means A is a point on the y-axis. A is a point on the y-axis. Now, I need to find the coordinates of A. Yes? Okay. Look, this is B. This is a line parallel to the BH is a line parallel to the x-axis. Therefore, it must be perpendicular to the opposite side. That means if this is OA, that means this is a line parallel to the x-axis. That means this must be a line parallel to the y-axis. If O is on the y-axis, A must be on the y-axis. Isn't it? So this then is perpendicular. A lies somewhere here. A therefore will have coordinate 0, lambda. Do you all understand this? Huh? And realize that AH must be perpendicular to OB. Yes or no? AH must be perpendicular to OB. Yes or no? Right? What's the slope of OB? The slope of OB is 4 minus 0 by 3 minus 0, 4 by 3. So what's the slope of AH? Slope of AH must be minus 3 by 4. Right? Therefore, slope of AH is lambda minus 4. Right? Lambda minus 4 by 0 minus 1. Yes or no? See? What's the slope? y2 minus y1, lambda minus 4, x2 minus x1, 0 minus 1, lambda minus 4 by minus 1, and that must be the slope of AH, which is minus 3 by 4. What do you say? And therefore, lambda must be what? 4 plus 3 by 4, 19 by 4. Clear? So option D. Coordinates of A would be 0, 19 by 4. Clear? Okay. Let's look at problem 23. Clear? Have you all understood this? Can I wipe this off? Can I wipe this off? This line is x plus 2y equal to 4. That means x by 4 plus y by 2 equal to 1 is this line. Now what would be the point A? Its x-intercept 4, 0. This point. This point is B. What? 0, 2. All right. Confused? Okay. Now on this AB, a square is constructed in this sense, This is a square constructed. AB, CD is a square constructed. ABCD is a square constructed on the line away from the origin, away on this side. That's given in the problem. We want to find the intersection of its diagonals. That means we want to find the intersection of CA with BD. CA with BD. This is what we want to find. Right? Now, first of all, what's a side AB? Root 16 plus 4, root 20, which is 4 root 5 is the side AB. 2 root 5, sorry, 2 root 5. 2 root 5 is the side AB, right? Now, if I look at the midpoint of AB, what's the midpoint of AB? 2 comma 1 is the midpoint of AB, right? What's the slope of AB? What's the slope of AB? Minus half. Now, suppose the diagonals intersected at a point G. Now, can I not say from ordinary geometry that GM must be perpendicular to AB? Can I say that GM must be perpendicular to AB? Right? Now, what's the slope of GM? Slope of GM. That means tan of the angle that GM makes with the positive direction of the x-axis will be 2. Because the slope of this is minus half. The slope of this will be 2. Right? That means we have a line like this. M that has coordinates 2 comma 1. G whose coordinates we want to find x comma y. And tan theta for this line is 2. That means sine theta for the line is going to be 2 by root 5, isn't it? If tan theta is 2, sine theta is 2 by root 5, cos theta will be 1 by root 5, yes or no? Do you require my help in finding sine theta, cos theta given tan theta? Huh? No, na? Okay. Now, will this not be half the length of the side? Right? So the side is 2 root 5. So GM must be root 5. So this is root 5. That means if this is my h comma k, suppose a reference point, mg is r, which is root 5. Then can I not say x is h plus r cos theta, y is k plus r sin theta? Can I say that? Right? So x then, parametric form, x must be h, which is 2 plus r is root 5 into cos theta. Cos theta is 1 by root 5. So that makes it 3. Right? What will be the y coordinate of G? Y would be k, which is 1, plus r sin theta. Y is k plus r sin theta, parametric form. K, which is 1, plus r sin theta, which is 2 by root 5. So that makes it 3. So the coordinates of G would be 3 comma 3. Got me? Will mg not be half the length of this side? This is parallel to this. This is root 5, this is root 5. This is 2 root 5, this is 2 root 5. So each of these must be root 5, isn't it? The length of the side is 2 root 5. Can I not say this then? This must be half of this. Clear? Three comma 3. So option C is correct. Option C is correct in 23. So there is a pair of straight lines given, ax squared plus 2hxy plus by squared equal to 0 is a pair of straight lines. Through a point A on the x-axis, a straight line is drawn parallel to the y-axis. First of all, let me depict these two lines. These are two lines passing through the origin. This is one line. This is the other line. These are the two lines passing through the origin, represented by this equation. Now, through a point A on the x-axis, a line is drawn parallel to the y-axis. Through a point A on the x-axis, this is a line drawn parallel to the y-axis, this dotted line. And this is B, this is C. This is B and this is C. And it's given that AB is BC. It's given that AB is BC. Now I want to connect H, A and B. I want to be able to connect H, A and B. Clear? Right? Now, suppose A has coordinates x comma y, x comma 0. B has coordinates x comma y, right? Now, if this is y, then this length will also be y, because AB is given to be BC, so this will also be y. So coordinates of C would be x comma 2y. Yes or no? That's given, yaar. It's not my choice. No, I mean, do I need to draw it to scale? It's not a class on construction, right? Then it need not look AB equal to BC. You're not going to use vernier calipers to measure that. Come on, yaar. Don't waste your time and my time on trivia. In any case, if the slope of this is y minus 0 by x minus 0, m, then the slope of this, if this is y by x, the slope of this, then the slope of this is going to be 2y minus 0 by x minus 0, right? The slope of this would be 2y minus 0 by x minus 0, which is 2m, yes or no? That means between these two lines, one line has slope m, the other line has slope 2m. Yes or no? Now look at this. Let me divide by x squared this equation, b into y by x whole squared plus 2h into y by x plus a equal to 0. The roots of this will be the slopes of the two lines, isn't it? It will give me two values of y by x. Y by x equal to m1 and y by x equal to m2, where m1 and m2 are the slopes of the two lines represented by this. Yes or no? And m1 is m, then m2 is 2m, right? So m plus 2m, the sum of the roots of this equation, the roots of this equation would be mn 2m, right? Sum of the roots is going to be minus 2h by b. That is 3m equal to minus 2h by b, right? The product of the roots of this quadratic, m into m, which is 2m squared, product of the roots, and that's going to be a by b. Yes or no? Between these two, I want to eliminate m, because I want to connect h, a and b. I want to be able to eliminate m, right? So all that I need to do is 2 into m squared. M squared is 4h squared by 9b squared. A by b, that will give me 8h squared is 9ab. 8h squared is 9ab is what I get. That's a required relationship. That's a required relationship. Got me? There is a point, say A, 3 comma 4. There is a ray of light that comes this way at some point, goes this way, is incident on the x-axis, and again gets reflected from the x-axis and goes to a point B, say 8 comma 2. We want to be able to find x. This point is x comma 0. We want to find the coordinates of this point. Clear? Now, after all the inputs that I offered to you in the last class, it shouldn't be difficult. Okay. If this is the mirror, this is an object, this is an incident ray, then the reflected ray, where is the image of A? Image of A is going to be somewhere here. Right. The image of A is A prime, which is minus 3 comma 4 would be the image of A with respect to the y-axis. That means this reflected ray seems to be coming from A prime minus 3 comma 4. Yes or no? Okay. Now, think of it like this. Think from principle of reversibility of light. Think of a ray of light going this way, then after reflection it will go this way. Right? So if this is an object and this is the mirror, then the image of B is where the reflected ray would seem to be going from. So if a ray of light were to be going this way, then it would get reflected like this, and it would seem to be coming from the image of B with respect to the x-axis. And the image of B is B prime. It's 8 comma minus 2. Yes or no? Now this point P is x comma 0. Very clearly A, P and B are collinear points. A, P and B are collinear points. Very good. Now what's the slope of AB? Slope of AB is 4 minus minus 2 divided by minus 3 minus 8. Right? Slope of AB is 6 divided by minus 11 is the slope of AB. See, 4 minus minus 2 divided by minus 3 minus 8 minus 11. Yes or no? 6 by minus 11 is the slope of AB. And that must also be the same as 0 minus minus 2. That is 2 divided by x minus 8. Right? So that gives me minus 3 into x minus, or rather 3 into x minus 8 is equal to minus 22, etc. X is therefore known to you. Clear? See? 3 into x minus 8 is minus 11. Is minus 11. 13 by 3. X is 13 by 3. 13 by 3. 4 1/3 is the value of x. And similarly, you could have also found the value of y. Isn't it? From collinearity considerations, you could have found y as well. Does it make sense? So, there are these two lines represented by ax squared plus 2hxy plus by squared equal to 0 are the two lines. Right? This is one line. This is the other line. All right. Now what is it that I want to find? This is a pair of lines. I want to find its mirror image about y equal to 0. Y equal to 0 is what? The x-axis. Right? Now suppose x comma y is any point on this pair. On this pair. Suppose x comma y is any point on this pair. Alright. Then on its mirror image about y equal to 0 is going to be x comma minus y. And this must lie on the pair of lines that we are seeking. That means if x comma y satisfies this, then x comma y must be a point on the mirror image of this. That means in this, if I replace x by x and y by minus y, I would get the mirror image of this about the line y equal to 0. All that you need to do is replace x by x and y by minus y in this equation to get the mirror image of this line about y equal to 0. That is about the x-axis. That means replace x by x, which remains x, y by minus y, minus 2hxy, y by minus y, this will remain y, right? By squared. This would be the mirror image of this pair about y equal to 0. Replacing x by x and y by minus y will give you the required mirror image. Yes or no? All's good? Wasn't that difficult, isn't it? Can I wipe this off?
But if we replace it with x and minus y, that means that lies on the same equation.
No, not on the same equation. See, all that it means is the equation of the image can be obtained from this equation on replacing x by x and y by minus y. That's what it means. Why is it the same equation? How is it the same equation? Huh? No, both. So this could be a point on any of the two lines, by the way. It could be a point on any of the two lines. The same thing will apply for the second line as well. This could be a point on any of the two lines. Its mirror image about y equal to 0 will still be x comma minus y. Yes or no? Now P and Q are known to be parameters. This then would be family of lines. If P and Q are parameters, this then would be family of lines. Now, let's examine this family. This could be rewritten as P taken common, x plus y minus 1, collecting all terms that contain P, plus Q into 2x minus 3y plus 1 equal to 0. If P and Q are varied, I get different lines out of this. But all these lines thus produce would be, see, this line is a linear combination of two fixed lines, x plus y minus 1 equal to 0 and 2x minus 3y plus 1 equal to 0. This is a linear combination of these two lines. Therefore, this line must pass through the intersection of these two lines, yes or no? And there is a fixed point of intersection of these two lines, whatever it turns out to be. Have you obtained the point of intersection? How much is it? Huh? 2 by 5 comma 3 by 5. That means these two fixed lines pass through 2 by 5 comma 3 by 5, and this, which is a linear combination of these two lines, will also pass through 2 by 5 comma 3 by 5. So this is a family of lines passing through a fixed point. What is that point? 2 by 5 comma 3 by 5. This set of lines therefore will represent a bunch of concurrent lines. Is that all right? By no means have I suggested that all that had to be done was done. But for sure, the foundation has been set. We could have gone ahead and solved many more problems on straight lines, but yes, I will. But even before I formally solve more problems in the class for you, it is required that you have an independent excursion with straight lines on problem solving. Right? Whatever we have done in the class, you must visit those concepts one more time, visit the problems one more time, independently solve those problems, see if you can find superior solutions, be a little more ambitious, get on to problems from other textbooks that you have, let your mind dwell in these ideas independently before I make you go through another sheet of mine, which would be, let's say, a closing sheet on straight lines. By the time you are done with that, we would have made some progress in some other areas and choose to come back to this when you tell me you are ready for another sheet on straight lines. But until then, it's just going to be waste of time if I keep dumping one sheet after another. It will not make sense. But in terms of ideas, in terms of positioning ourselves in straight lines, we've done our bit, right? There is a concept that I would deliver to you in a little while, which is a pending remark on straight lines. Stand by.